Thank you, everyone, for joining my talk this morning, the first talk of the day, among other folks, too. And so thank you for choosing to come to my talk. But let me first ask, I think I'd be able to see some of you, how many of you are already working with generative AI? I'm just curious. Yeah, so, okay, so a few of you. So let's see, are you mostly doing Python or maybe Java? Anybody doing Java? Okay, so a few. So you're using LangChain 4J? I'm kind of assuming. Yeah, so yeah, I can see like fewer and fewer hands. But there are some of you are working on it, so that's great. But as such, too, just so you know, this talk is meant to be for introductory kind of folks, and but it by no means is like you're brand new. You are very experienced, and some of you are very experienced, but are already experienced. So it's meant to be as an introduction to even to those of you who are new to AI and generative AI. So bear with me if it becomes some of the things are more introductory. So, okay, so let me start. So making sure is the time. And so enter the brave new world of GenAI with vector search. And I kind of deliberately choose this title because brave new world, as some of you, most of you are aware, is actually a book, right? A science fiction futuristic book written by Aldous Huxley, an English author. And it kind of talks about kind of a utopian or dystopian kind of society existing in the future. And I don't mean to say Gen AI is kind of becoming dystopian, but certainly too it carries with it that type of kind of connotation, right? Something in the future. But also, does it mean, I think the big question is, does it mean it is going to take control of our lives? And certainly, no, I don't think so. And it's also, as some of you already are working on it, as we know, I mean, what has come out certainly has surprised us, and also like make us kind of wow, it's doing all these things. But I think, as I think more about it, I think it's going to take some time before it can become ready for prime time, for production. And I was kind of thinking, like, how could we kind of, compare, this Gen AI with something in history. Somebody's waving. I'm sorry, is somebody waving at me or something? Sorry, but anyway. But to me, right, I think it's sort of like, the history of airplanes, of aviation. As we all know, it took some time before airplanes can carry people in huge quantities, huge number, and flying across the ocean. So I think likewise, too, Gen AI is like right now is, wow, amazing, we can fly to the sky. But probably it only like deals with a couple of, taking care of some of the things maybe. I think the thing is equivalent to maybe aerodynamics. We're starting to discover that. But as we all know, when you fly an airplane, it's much more than that. You have to deal with unknown circumstances, all of these things, which will take time to become really usable, is what I'm looking at. But anyway, so without further ado, I'm going to start. So I think it's an exciting thing. It doesn't look like my clicker works, so I'm just going to use this. OK, so this is my agenda for today. First, just kind of an introduction, who am I, and also giving a brief background of AI, because presumably, and maybe some of you or most of you, being more of a Java-focused conference, and that's what I'm finding is that a lot of Java developers may not be ready, or just for whatever reason, right? We're too busy with all the enterprise stuff and not looking into AI. So I want to give a bit of an introduction to AI, and also specifically to generative AI that's kind of captured our attention, right, in recent year or so. So a bunch of like introductory materials, the terms, and including RAG, and also some vector database. And because this is just a 45 minutes talk, so I'm just going to be brief to some of these things, but at least touch upon some of these key concepts. And then if there's time, I can do a quick demo too, but it may not actually be the case. But that's OK. Tomorrow I'll also be doing a workshop too, just so you know if you're interested. And so, yeah, so that's essentially the agenda for today. And who is Mary? So I actually just started my new job last week, and this company called Calibrity is based in Ohio in the United States, and I'm from Chicago myself, and I just joined them, and for the previous 6 years or so, I was a developer advocate, and I was here at JNation last year as well, so maybe some of you have come to my talk last year, and I was talking mostly about event streaming, previously reactive systems, distributed systems. And then about 7 months ago, my company too decided at the time, was DataStax, was saying that, oh, let's all switch to doing generative AI, which I actually welcome, because I think, as software developers, engineers, and we should keep learning new things. It's even my principle. I think it excites us, and it's good to be aware of. So that's how I got into generative AI about 7 months ago, and started actually quite fast, have to start understanding it, being able to present. So I started talking about generative AI, and specifically too for about vector database, and which will be the focus of tomorrow's workshop in my case. Anyway, so that's me. I'm also, I'm very passionate about advocacy, but I decided to become more doing consulting work, but still doing partly evangelization. That's me. And I'm also a Java champion, and also I'm the president of the Chicago Java Users Group. So if you want to join us, we are back to running in-person meetups, but we are also doing it virtually as well. So and then it's also being recorded on YouTube too, so if you're interested. Okay, and then these are just some of the things I've worked on. And I was previously at IBM as an advocate, and then DataStax, and then, like I said, I'm now a practice lead for Calibrity in doing AI. So that's me. I won't spend as much time. So let me then start. A brief background of AI. So when I kind of looked into the history book looking at AI, if we kind of take the current era of AI, we can kind of trace back to the near kind of old times, meaning just roughly 100 years ago, slightly less. 1930s, that's when the new golden age of science fiction came out, as we all know. And so as you can see, this particular slide, too, I got it from this particular link here. And if you're interested, I'll be sharing the slide deck if you're interested. And I find it to be quite comprehensive in terms of highlighting some of the key moments of the AI history that we're in. And then I also added in one towards the beginning, because I go to different conferences, and there are kind of audiences who pointed out to me, I need to also include very early stage. 1943, by Warren McCulloch and Walter Pitts about perception, too. It's an algorithms on supervised training. So all those things. And then as we kind of navigate through this timeline, there's also 1950, as we all know, the father of modern computing, the British computer scientist Alan Turing. He came out with this book and basically questioning, can machines think? Now, the thing is, too, is that that's what we are all striving for right now, but I don't truly think, let's say generative AI, it seems like, yes, it's smart and everything, but to me, we have to do a lot of prompting, right, to give it input in order to kind of get the results that we want. So it's just my opinion. I feel it's not really ready yet, meaning we still need to guide the machines to think in the way we want the results for. I think it's truly, we can say it is machines thinking is if we just give it some idea, some very fuzzy idea, maybe the prompts cannot be exact, and then it will give you back what you want. I think that will be kind of closer to what we truly want, is have machines to think. However, I don't think it's really the desired outcome at times, and so that's also the challenge too, as we are going more and more into the research, fine-tuning this whole space, is that I think we need to come up with ideas, and I'm sure there are already plenty of research being done, is to ensure that there are no hallucinations and also ethical outcomes too from it. So anyway, but just let me go back to the history. So as you can see, this whole timeline, and I won't get into all of the details, and you are welcome to take a look at this, this timeline on this link too. And as I kind of wanted to point out too, we see that there are a lot of research being done too. And because I work for IBM, I thought 1997, that was interesting, of IBM having the Deep Blue machine playing chess, right? That's a dedicated chess machine, and it's basically supervised type of training too. And so they defeat defeated Garry Kasparov, who was the chess champion of the time. And then, and so on and so forth, and that's where it's kind of, precursor to where we are today. Okay, so without further ado, go more into it now. So when we think of AI, what it is all about is really automation, not just doing the mechanical piece of work that we want to kind of relieve ourselves of, but also having it to think. I think that's the ultimate thing, right? To think properly is what I advocate for. So let's kind of also then clarify some terms in this AI space. And if you kind of look at it, there's artificial intelligence. To me, if you look at an onion, it's like the whole thing. This space is artificial intelligence. It's intended to mimic human behavior and our intelligence too, right? And kind of the knowing how the pattern of humans and living entities are, in terms of doing all these things is artificial. But that's not enough. So that's why too we go inside this onion. As you peel it, then there's the machine learning layer. That's actually the techniques. It gets more into techniques of how a computer is able to learn is by, supervised or unsupervised training and also like reinforcement learning, all of these terminologies that you probably have worked with, all of these things. And basically, too, it's about you not even have to like actively train. It's basically you're giving a huge text or some data feeding into the robots and having the robots think, to learn on its own. That's machine learning. However, we know that just that alone, this learning is not enough because what really makes it able to think is the neural network layer, which is getting into the core of this is the deep learning, is the techniques that is able to perform machine learning and also perform machine learning that's inspired by how our brains, our whole nervous system works to this neural network of neurons. So this is kind of that was a common thing to describe AI, machine learning, and deep learning. So let's kind of like fast forward and look into our fascinating generative AI era. As we all know, it just came out pretty much less than a year or two ago, November of 2022. So GenAI is essentially a disruptive field of AI. So it has the potential to change the way how we create and consume content, which we are already seeing now. And it's basically generate contents, and it does rely on prompts. So you do need to give it input. And as I mentioned earlier, is that the input you have to be very precise to be able to guide the bot to kind of generate what you need. And it's essentially, too, it makes use of both machine learning and deep learning to produce all of the results, all of the contents. Just the thing to point out is that GenAI is kind of a natural evolution. At least that's how I look at it, from predictive AI. So there was already AI activities going on, but previously it was predictive because we are also learning from data. But you notice that predictive deals more with data or outcomes that has a time kind of constraint or time limit to it. For example, like business forecasts, weather forecasts. You just want those to be like weather forecasts for the next month, for example, and then business forecasts for the next 2 years, and it's based on some previous data that it tries to draw a conclusion out of. However, for generative AI, first of all, it's taking input as prompts. Not only you don't need, necessarily like doing things the old traditional way. It's basically you can talk to the computer, talk to the robot as though you're talking to another person. So that's the natural language input part is much, kind of stronger or kind of fancier than it was before, right, with predictive AI. And not only that, too, generative AI tends to focus more on like the creative side of contents. For example, writing an essays, designing a dress, right, and writing code, and so many of us are aware of, right? And so that's the kind of a distinction between generative AI and also like predictive AI. Okay, so it's really quick kind of pointing out to when this generative AI movement started. So the research only was kind of started, like, let's say it keeps going, but then the last, before it happened, right, that was in 2003, so roughly 10 years before or actually I should say 2 years, right, before the debut, 2022. But actually, then go back to 20 years ago, 2003, that was the first feed-forward neural network language model that's kind of pointing, the whole evolution to the direction of the GenAI that is today. And then in 2011, Apple brought Siri to the mass usage through the iPhone, as we all know too. And then 2013, there was a group of Google researchers. They work on this concept, right? This thing called word-to-vec. Essentially, it makes use of natural language processing model and this technique that employs neural network to learn word associations too. So that kind of like forms the basis of how the vector database are able to do similarity searches. Pretty much is kind of stem from that, the word-to-vec. And then 2017, there was a group of Google researchers. They work on this simple network architecture called the transformer. So if you've been following all of these research papers, I think there's really kind of famous tagline that came out of it was, attention is all you need. So that's where it came from. So all that too is like leading to where we are today. And so now before we get a little further down, let's also understand the new players in this generative AI era too. First of all, when we kind of talk about generative AI, and of course we need all of the models too. The models is what kind of captured by the large language models, that LLMs that we as developers especially, that's what we work with directly. So these are just some examples of the more popular generative models that you have heard of. So first and foremost, OpenAI is the organization that kind of is in charge or governs and owns some of all of these famous models, of which GPT 3.5 that came out in 2022, November, so less than 2 years ago. And that really wowed the world because of its capability of just doing things like you just talk to it and it gives you the output. That was kind of very impressive too. But then as you kind of look around too, there are many other models also being done, but just want to kind of point out some of these too. So I look at GPT 3.5, then GPT-4 came out in 2023, so just roughly a year ago, that's GPT-4. That has a larger kind of data sets behind it too. And then there's also Codex in here, which is a model that's used by GitHub Copilot. That's for catering more for doing code generation. And then I also want to point out, too, there's Stable Diffusion, which is the first text-to-image kind of model, too, from Stability AI. And after that, it also kind of has led to, like, Dolly and Midjourney. I'm sure some of you are already using that to generate images and stuff. So those are the popular ones. And then one thing, too, just wanted to point out over here on the right side, BERT, too, which came out of, it's kind of like a pre-Gen AI kind of era. That's actually at Google. But interestingly, too, I'm putting a question mark now after my presentation at JCon in Cologne 3 weeks ago. Somebody said, BERT isn't really quite an LLM. However, I'm not sure. Maybe some of you also are working with. But from what my research is, BERT it stands for Bidirectional Encoded Representation Transformer. And from Google, it's an early research into like large language models. And it is actually supposed to be a model too. But some people didn't think it is quite a model. It's more of a transformer. So that's up to kind of interpretation. But certainly it is a precursor to the LLMs that we are so kind of like fascinated by in today, right? Okay, so that's that. And then there's also then other models too, for example, that came out of Llama 2, Llama from Meta, the former Facebook. That's open source and is free to use. And then there's also Cohere, Command R2. That's also kind of a popular one. And then Anthropic, which actually they came from OpenAI with Claude. Claude is really good with kind of writing essays towards that. It tends to be. Okay, and then there's also Whisper, which is kind of more of the audio, kind of dealing with that too. So these are kind of like a sample of what generative models are. And then with the models, too, again, it isn't as useful as if you develop apps, which there are tons of apps being developed now. But kind of these are like just highlighting some of these ones. First of all, too, ChatGPT, as we all know, is kind of basically based on GPT, that model. Kind of fascinating us, all of these things. And then also another one is Gemini, too. That Gemini came out from Google, and that's a multimodal kind of model to it, too. So it's kind of quite fast. privacy. I still haven't used it yet. It came out like three months ago or something, and it's essentially replaced the previous Bard 2 that works with Google AI too. And then there's also GitHub Copilot, which I point out already, and also maybe a lot of developers are maybe already using it. And then there are also other ones too I was just kind of putting in here. But again, there are tons of all of these generative apps out there too, and you're probably already developing some of those. Okay, so one of the things I wanted to point out in generative AI too, one area is of significant kind of interest. There are a lot of research too, and there are already examples as it is kind of popping out too. It's basically modality. As we all know, it first came out, it's more about text to text. So you'll be typing in some input, and it comes out result is another text. However, what is more kind of even more useful, as we all see, through, for example, stability diffusion is text to image, that you can just type a text, and then there will be generating to you pictures. Or there are also now like video, which OpenAI also just came out with Sora. That was 3 months ago, I think in March, Sora. And it's pretty fascinating. You can be describing a scenario, and it generates the video for you. It kind of looks like real-time and very real-life-like, too. And then there are also, of course, images, audios, and also code. We've seen that. And also like three-dimensional mode, too. So this is an area that's kind of heavily, there are lots of research being done to it, too. And as I mentioned, too, Gemini, too, from Google, too, is a multimodal kind of model, too, to it. It can handle text, images, video, all of these things, and in real time as well. So again, I haven't tried it yet, but maybe some of you are already trying it. So just so you know, too, Gemini, and you can interact with it through the Google API, too. Okay, so how about people, right? We talk about these models, these apps, all of these modality. But people, too, are what we care about. We are the people doing the work or participating in this whole movement. So first of all, just wanted to point out there are already data scientists. Their job is mostly to focus on the data, what it should be, right? And they tend not to be the ones that know how to implement things, right? Like us. For example, I'm assuming most of us are engineers here. So we are on the developer side. There's data engineer, AI engineer with focus on doing AI type of kind of implementations. And also, too, another new area that I'm also starting to try to do more research on is doing operations, ML ops. Essentially, to ML ops, think of it more like DevOps, but you extend it to kind of help with operationalize all of the machine learning type of activities, maybe in pre-training the models, and then later for inferencing, all of these things. And basically, it's still open up to a lot of research and understanding. And as such, and that's what I wanted to also reassure all of us, because everybody is like worrying about, okay, AI, Gen AI is going to take over our jobs. You can do Copilot to do our jobs. And I don't think so, right? I mean, right now, it's not able to think well. I mean, it can do things, but you still need to go check to make sure it is right. So by that alone, I don't think it's ready yet. I think it still requires all of our intelligence to make this more robust. And we need to be actually overseeing it, making sure the robots do its job too. So it's really far from taking over our jobs is what I'm trying to also say. And there are also new positions coming out, and I do believe even on the regulatory side, right, you need to kind of guarantee what it gets generated is correct. So as an example, just want to point out to you, I was just kind of at a meetup as listening to my ex-colleague talk, and he was saying that someone actually went and asked one of the, I forgot which model, but was just asking, was describing, well, I'm feeling depressed. I'm not very happy. I can't do what I want. All of these things, right? Very negative. And guess what? The chatbot came back and said, why don't you go jump off the bridge? So as such, if it comes back with an answer to tell you to jump off the bridge, we know it is not right. So how can it be, right? And so these kind of things, right? Yes, that's why the LLMs is able to answer, because it's churned through a lot of examples that are out there, and maybe it's talking about these negative things, but the LLMs is not capable of intelligently figuring out, is it the right thing to do? And people can say, go design a nuclear bomb, and they would go and do it. So all these things, right? And so bear in mind that I think we need to kind of be aware of all of these ethical implications. Don't just say it can do the work, but also we have to ensure that what we're going to do is ethical, is the right thing to do. Anyway, so these are like the players, and we are responsible for making it right, making it good too. Okay, so now let me then move on to some of the terminologies. GPT, Generative Pre-trained Transformer. So essentially, too, what it does is it takes simple prompts, and these are in natural human language format, right, as input. And what it does, too, is that it does what is called like pattern matching, or sometimes we say it's search. It is sort of a search, but it's actually what is called similarity searches. As such, too, GPT, what it does is it answers questions for the prompts, and it produces contents such as essays, have a fashion that's being designed for you, and generate some videos, maybe even a movie, short movie, whatever it is, write a song, all these things, writing our program, all of these things is the work of GPT. So it came out, this GPT, actually only like about 6-7 years ago, 2018, at OpenAI, there was a paper on GPT. That was version 1. And then very soon after that, version 2, GPT-2 language model, also from OpenAI, it has a larger data set that it got trained on, and then it became kind of showing its promise. And then very soon, too, after that, then we can tell, 2022, not only is it text-to-text, there's also stable diffusion, as I mentioned, text-to-image model coming out. And of course, the rest is history. All of these things that are being done right now, Gemini can do multiple modals, things too, and there are plenty of models coming out. So just wanted to kind of quickly point out. And of course, ChatGPT releases GPT 3.5, which is an AI tool that reached 1 billion users within 5 days in November of 2022. And then, of course, then there's 2023, all of these things, and I won't kind of mention now because all of the history is happening now, and it's happening really fast. Okay, so now, next thing is NLP. So what is kind of making all of this magic happens is essentially this study, this interdisciplinary subfield of computer science and linguistics. And so that's what it is, right? It's able to understand languages in natural language, spoken languages form, and being able to interpret that. And that's a big kind of advance and milestone in human computer science, too. So the idea is that you want to process natural language data sets, right, that came from huge corpora of text or speech kind of data, right? And it uses like rule-based or probabilistic machine learning and neural network to kind of process all of these. So it enables computer to learn from the contents too, including, not just like generating to you results that's kind of exact. And in fact, it is becoming able to figure out, kind of a context and results, what you're looking for. It's capable of generating more than what you're asking for and giving you insights into things too. So that's the NLP. And so now the next thing is basically, let's talk about large language models, LLMs. And that's what we as developers, we interact with all the time, essentially. It is a type of machine learning model, and it's a foundation type of model too. And notice that, while it is amazing, the thing is, though, it's kind of actually limited, too, if you kind of think about it. Yes, it can hold up a lot of data. It processes a lot of data. But the thing is, though, it's very expensive, right? It takes a lot of GPUs. Even with GPUs, it's not a day's job or an hour's job. It probably can take weeks to kind of train a model, for example. And so it's not like for, I'm talking about these general purpose LLMs like ChatGPT, for example. And it will take a lot of time, and it's not like us can go and train it ourselves. But what we can do, though, on our maybe individual workload is we can, like say we work for an insurance company, you can actually train like small models. They are much smaller in comparison to, especially if these models are only meant to be for private use, for example. But otherwise, too, general purpose LLMs are very expensive and not, up to everybody to do it, too. And so, yeah, so as such, it is amazing, but it's not amazing. It has its own limitations. But let's kind of go back to that original diagram. But let's kind of take a look. What is an LLM? How does it fit into this AI, ML, deep learning diagram? So as you can see, right, the same, we have deep learning inside in the core of it. But now we can see more clearly how this generative AI fits in. There's image gen and LLMs, the transformers, kind of inside the deep learning part. And it's also leveraging a lot on data sciences, kind of theory and kind of mechanisms too from data science. And also too, it leverages on natural language processing to help it to figure out the prompts and generates what people would need to. So that's how kind of, if you take a look at this diagram, how it describes it. So. Okay, so now the next question is then, how can I work with LLMs, right? That's the thing, right? With all this theory or how it is, where things are. But essentially, too, just wanting to point out to you, right, there are libraries that essentially, just like anything, we work through APIs. So first and foremost, I'd say right now, LangChain is probably the most popular ones. And LangChain, by the way, is all Python, too, but also has JavaScript and TypeScript to it, too. It is, no doubt, is actually very popular. If you go everywhere, everybody is talking about LangChain. And then there's also Llama Index, too, also another very popular ones. And if you take a look into, there's a site called OSS Rankings, and you can find out the rankings based on number of GitHub stars. And by the way, these are all open source libraries too. So you can look into those. And Llama Index also is Python and JavaScript based. And then there's also from Microsoft, there's Semantic Kernel. Semantic Kernel too also actually has Java interface, has a Java SDK to it too. And then there's also as such as Gemini API that allows you to work with Google AI. And then also, too, one thing I want to point out is Hugging Face, too. So and then you might be wondering, well, where do I get all of these models, right? So as such, Hugging Face, if you're not familiar with it yet, think of it like a GitHub for AI models and GenAI resources. So you can go to Hugging Face and get an account and download a lot of models. There are, in fact, a lot of models in there if you are not familiar. So you can get, but make sure, too, when you download, a lot of these models are very big, too. So make sure you have enough resources to hold these LLMs that you want. But as such, again, you get tons of those. So it's just a place where you share all of the models, too. Okay, so here, JNation having a very strong kind of focus on Java, so I can't help but also wanting to share with you some of the Java-based API frameworks, too. So first and foremost, I'd like to point out LangChain 4J. Notice that it is using the name LangChain, and it's kind of taking the concepts of LangChain, but it's not from the same group of people. But it is certainly kind of taking a lot of concepts and kind of carry on the spirit of LangChain, but it's basically implemented in Java. So it's a Java API. That one I'd say I would recommend, and some of you are already working with it, LangChain 4J. And then again, Semantic Kernel also has a Java SDK to it too. And then there's also another one called JLlama. This one is a bit more of a hobby thing. It's actually my ex-colleague. He's the architect at DataStax, where I was. And it's essentially Llama, but it's Java version of Llama. And it's a bit of a hobby, I'd say. He started off like that. And yeah, so that's that. And it's all open source, too. And then also another library called JVector, too. It's also from my previous company, DataStax. It's basically Jonathan Ellis' project. Jonathan was the Apache Cassandra project lead before, and then he still is with DataStax. But he looked at, because a lot of vector search kind of capability being built in to do similarity searches, because all of the data, as I will be talking next, is about vector database. So JVector is essentially Java implementation based on Project Panama, the vector API. So he has done that, and primarily right now is working with Apache Cassandra. But then it's kind of intended to help you with speeding up vector searches too. So that's JVector. It's a bit lower level library. And then there's also one more that I want to mention is llama2.java, and that one is directly a direct port from Llama, the C version too. So these are Java-based API frameworks if you want to choose to that. And so now you're wondering too, then how does it work, right? LangChain 4J. This is just a very really Hello World kind of implementation. But again, right, as you can see, this is an example. And so all you see is basically in the main routine, you just need to make sure you have an OpenAI. You go to OpenAI and get an API key. You want to associate your model with the key, and then with that, you can then use the model to generate your output. And in this case, again, Hello World is just all hard-coded, it's Hello World, and then you should be able to see that as a result. But again, this is just a little glimpse into how you use LangChain 4J. And as such, too, there are also embeddings and all of these other things, too, that comes with it, but I won't have time today to go through it. Tomorrow workshop, I will step through some of these with LangChain 4J. Okay, so the next thing I want to talk about, too, is RAG. And maybe some of you, again, have heard of this, Retrieval Augmented Generation. So as such, too, why this pattern? This too, as such, is an architectural pattern. It's not about implementation, because implementation is up to however you want to do it. And of course, there are already libraries out there, open source or not open source, that you can do. And essentially, too, what its purpose is to extend or kind of overcome the limitations of what LLMs cannot do. And as such, right, LLMs are big and huge. But the thing is, though, let's look at ChatGPT 3.5 as an example. It came out in November of 2022, but the data, though, the cutoff is up to only 2021. Then what will happen is that you try to interact with the ChatGPT 3.5 chatbot, and then it comes back with answers that is not capable of knowing because it wasn't trained on data beyond 2021. Then what do you do, right? So this is a technique that essentially the industry, kind of everybody is crazy about talking about RAG, and it's just the architectural design or kind of guidelines, so to speak, right, to help you to kind of fill in the gaps. So what it is a hybrid framework that integrates like two components of these RAG models. One of which is, as such, retrieval, then you need the retrieval model, and then there's also generative model, is what generates you the outcome. So the idea is that the purpose is to basically produce text that's not only contextually accurate, but also enriched too with what you can do. It's essentially to the generative model's job to enrich it too. So thank you. Yeah. Okay, now then let's really first look into the role of the retrieval model. So the retrieval model, think of it like, okay, the LLMs doesn't have what I need, so I can actually feed external data to it. So think of retrieval model as like a librarian. I'm pulling in relevant information from a database, another database, or another corpus of documents too. It also can be an event stream, for example, right? If you're familiar with data stream, you can also feed that in to help you with your retrieval. So from this retrieval model, then the information is then fed into the generative model side. So the generative model side acts as the writer, and I'll take all of the information, I will enrich it and respond it back to the user who's doing the chat, right, requesting all of these information. So as such, too, this is summarizing. Role of the generative model is like a creative writer, and it's just synthesize all of the retrieved information into kind of coherent and contextually relevant and enriched kind of data back, right? So what does it do? Yeah, so they take the raw data, right, selected by the retrieval model, and give it a narrative structure, and then making the information easily digestible and actionable too. So that's the thing. It's actually not that complicated, right? It's just logical. We are already doing it. For example, Java developers, in your company, you're already doing a lot of extraction, taking data from streams, building data pipelines. So you can apply RAG techniques to do what you can do to fill in the gaps for what LLMs cannot do. Okay, so that's that, and then I only have maybe 8 minutes. So very quickly then, let me bring into the next topic, subtopic area, which is about vector database. So what is that, right? Vector database as such is a purpose-built database, and it serves up vector data type for complex machine learning purpose. And as such, right, as we know, right, in machine learning, now we're talking about data that needs to be rich, right? It's not just scalar data type that we are more used to. We're talking about, okay, I'm going to say something, it can mean many things, and so it's multidimensional in a sense, right, in mathematical terms. So in order to be able to query and do searches on these data, so what we do is that we convert the data into vector data type. So if you kind of look into it too, there are also terms of, it's called vector embeddings. So the idea is that you take, for example, a string that comes in, and then you want to convert your strings into vector data type, which is actually, if you look into a vector database, you search for that column that is of a vector type, you see a lot of numbers. They are also floating point numbers too. So essentially, you have strings being translated into highly precision kind of floating point numbers, and they are array of floating point numbers. So that's what it is. It's like numerical representations. So how do they get translated is basically you do need some embedding models to do it. So now, for example, OpenAI also has embedding models. So let's say you want to try to store your data into a database. You want to use some OpenAI model. Make sure that you store them in, and then when you retrieve it, you use the same model to translate it back for similarity searches. Otherwise, it would not be accurate, right? So that's the embedding. In a nutshell, that's what it is. So essentially, too, what this is also called in machine learning term, is called feature engineering. So for example, you have all these data you need to crunch through. You need to essentially filter in what is most relevant for your usage, right, in your application. It's what is called feature engineering. And also, too, it allows for searching based on a techniques called nearest neighbor, and one of which is approximate nearest neighbor. And as the term it kind of imply, it's approximate, right? It's not like fixed to. And as such, because we're trying to search for data. So let's kind of take a look at the next picture. This mechanism, what is a vector embedding, right? So this is kind of an example. So if you are a math person, if you have studied linear algebra, this should come natural to you. But let's say not everybody has the math background. So let me kind of explain a little bit. So what we are more trained on is always about scalar data type is single dimension. We see something is right there, and one dimension, that's it. But for vector data type, it's multidimensional, and this is an example of a two-dimension normalized vectors, but you can have actually as many dimensions as you need to. But for simplicity's sake, let's say I have some data in here, very simplified. I have different data being translated into different vector data. So when you kind of put on a graph, a two-dimensional, that's how it looks like. And as such, in linear algebra terminology, vector mathematics, basically it's not only the value of your data, but it's also the direction, like magnitude and direction. So that's expressed on this like as vector 1, v1, v2, and v3, like that. But let's take a look at a bit more kind of makes sense to all of us. It's basically, let's say, we have like these data being stored. Let's say the red ones, dog and house, that's how it's represented on the two-dimensional plane. These are the vector representation. Now I'm trying to do some search. Is for a cat, right? The blue line, cat. So as such too, that's how it is placed on that plane. So as you can see, if I'm searching for something about a cat, then most likely the dog, in this particular case, a simplified case, the dog will be returned because the dog is closer, right, in terms of approximate. It's not exact, but you can say it's an approximate algorithms. So this is just visually explaining to you how actually it works, right, with approximate nearest neighbor type of searches. So in this case, you're searching for a cat, for something, and it's basically a dog will return to you like that. So I hope that kind of gives you a good sense of what it is. Okay, I only have 4 minutes. So really quickly then, as I kind of mentioned, right, vector search is basically that was just a quick example, but essentially it's you go deeper into it, there are actually different layers of searches being done, and it gets very deep into a lot of these mathematical principles too. So these are like, again, the nearest neighbors embeddings. And vectors are a new type of data supported in a lot of the established vector database. And these are just some examples of vector database. These are open source like Milvus, PG Vector, which I'll be talking more about tomorrow. Is basically PG Vector is an extension to the popular Postgres open source database. And there's also Chroma and Fast came from Meta. And Quadrant, too, became quite popular, as well as Weaviate, too. And Weaviate actually has an easy kind of Java SDK, as I learned from Soham, who's I saw him at the JCon, and he told me about this Java interface to it. I have yet to give that a try. So if you're interested, and also, too, wanting to point out, too, essentially, too, okay, first of all, vector embeddings, what is it being used for? So as we can see, you can use for searches, similarity searches, clustering, product recommendations, for example, anomaly detection, diversity measurement, all of these things like classification. So a quick summary of these usages. And the problem with some traditional database in AI, you can certainly like build data pipelines in different kind of segments of data flowing through your system. But the thing is, though, with traditional database, remember that it can only handle like scalar, single-dimension data. So if you want to do searches, it's not going to be very efficient. But as such, I brought up that you can be building, like a system can be very complex. You have data flowing through different points. You can maybe use traditional database for drawing data from your database, right? Or kind of essentially traditional database, get your data, feed it into another pipeline that will go into a vector database. And as such, the usage of vector database in this case is to help you with similarity searches and storage as well. So. Okay, 2 minutes. Okay, really quickly, this is another diagram if you want to get more into it, how vector database, they all fit in. So this is a diagram that explains it. Okay, so now I think then I only have 2 minutes, really. So I'll just summarize. I don't have time today to do any demo, but tomorrow we'll do some, of course, at the workshop. So essentially, too, I'd say benefits of GenAI is that you can just ask and then you will receive, right? It's kind of nice, but make sure to ask wisely, right? So it's kind of think of the bot can help you speed up. For example, if you're coding, I think if you do coding, things like you want to try to do a quick sort routine, this lower level kind of coding, I think it would do a great job, so you can spend more time thinking of higher level, solving problems on more kind of high level thing. And the challenges, though, don't forget, there are hallucinations when the LLMs cannot answer you. It will give you back wrong answers, like that example that says, go jump off a bridge or something, right? So don't ever do that. So be very careful. And also ethical concerns, right? And always be aware of that. And then also real-time, up-to-date data. How about using RAG? There will be some ways of helping. Okay, so then I think with that, I only have a minute left, so just want to quickly share with you resources. If you're interested in this slide deck, this is the QR code and also the bit.ly link, if you're interested. Now, if you miss it, don't worry about it, because you can find me or I'll send it to the conference organizer. They can share that with you, too. Okay, and then also the open source ranking information on vector search engine, if you're interested. If you go to ossinsight.io, if you're not aware of it already, actually you can find out a lot of rankings of a lot of open source libraries as well. And for me, too, I also have share with you, I have a stream on Twitch, and also I multi-stream to YouTube. So this is my stream. I'm kind of trying to go back to doing more Twitch streaming, too, maybe once a week or once every 2 weeks. Usually is US Central Time, Wednesday, Thursday, or Friday, so that will be evening time in your time zone here. And then with that, I just want to thank you. I think I really have 5 seconds. So if you'd like to keep in touch, please, I encourage you to. I think this is a very exciting field. There's a lot of things to share. Nobody knows exactly, one or everything. We are all sharing. And I'm also the AI camp co-lead, too, in Chicago. So that's actually, I believe there's AI camp maybe in Portugal, too. So that's a great place to meet other folks who wants to talk about AI, generative AI. Anyway, so that you can get a hold of me on LinkedIn, or follow me on Twitter. And also, I have a Discord server, too, that you can ping me anytime, too. So with that, I want to thank you very much for having sat through my talk, and I hope you find it helpful to what you're doing right now. So thank you, and enjoy the rest of the conference. Thank you.